welcome to this Times Techies Talks. Today we are discussing GenAI and the hardware infrastructure to enable AI deployment globally and in India. I am Sujit John and I'll be moderating this discussion. We are doing this discussion in association with Dmatrix, the semiconductor company that's helping make AI computer code run more efficiently and use less energy. Generative AI has begun an incredible revolution. The world is now moving rapidly to build applications on top of the large language models that have been built. And these are unlocking phenomenal business opportunities. It's widely acknowledged that India has some of the best AI engineers in the world, and we are seeing them work on applications for India and the world. However, while all of this is happening, the world still faces a formidable challenge, one that impacts widespread adoption of AI. It's the exorbitant cost of running inference on these data infrastructure that we have. Because GenAI requires massive amounts of compute power, which in turn generates a lot of heat. As GenAI models become bigger and bigger, as more and more people use GenAI, these costs of compute and energy may become unsustainable. Today, we are going to discuss all of this, the promise of GenAI and ways to ensure it can be widely adopted and not be limited by the cost of hardware. And for this, we have three highly accomplished professionals. We have Sid Sheth. Sid co-founded Dmatrix in 2019. Prior to Dmatrix, he was at Infi Corporation, which was acquired by Marvell in 2020. It's Infi, not Infi. Okay. At Infi, Sid incubated and grew the networking business unit into an over 200 million business in 8 years. Prior to Infi, Sid was at NetLogic Microsystems, which was acquired by Broadcom. And he was at Intel, where he ran marketing and worked in R&D for cutting-edge networking chips and processors. Welcome, Sid.
Thank you.
We have Sandeep Alur. Sandeep is CTO at Microsoft Innovation Hub in India. He has 25 years of experience spanning 3 IT companies. He started at Genesis Software, moved on to Wipro Technologies, and then to Microsoft in 2008. So he's been with Microsoft for 16 years now, and he's led large and complex projects for customers in North America, UK, and India. Welcome, Sandeep. And we have Pradip Thaker. Pradip is India country head and VP of engineering at Dmatrix. He has had a 30-year career in the semiconductor industry, split equally between the US and India. Prior to Dmatrix, he worked at Marvell Technology. Under his leadership as India country head and VP of engineering, Marvell India grew to be the second largest geography of the company after the US. Prior to Marvell, Pradip worked as country head and senior director of engineering at Geo Semiconductor, an automotive fabless startup. Welcome, Pradip.
Thank you.
Let me start by asking Sid. Sid, tell me first, what led you to found Dmatrix? I mean, you had great careers in Broadcom, Infi, which was acquired by Broadcom, and then you worked at Broadcom also for a while, is it, after the acquisition?
Yeah, that's right, earlier in my career. Yeah.
Okay, so you left all that and decided to found Dmatrix.
Right. Well, I mean, I'd like to always tell the story of how the company was founded, right? We had great, cushy jobs, both me and my co-founder, and there was really, we could have happily run the business that we were building back at Infi. I'd like to brag a little bit about the fact that the team that has founded Dmatrix is a very unique team because in the last 20 years, this is probably the only team that has built a business in the chip industry that has grown to over $1 billion in revenue. Right? I don't think you can find very many teams on the planet that have done that in the last 20 years. So it's already a pretty unique team. But we wanted to embark on something that would solve a really large problem for a lot of very large customers. And one of the advantages we had when I was at Infi was we were selling products that were used to connect AI computing clusters. So we were building what we call the interconnect products. So these are the highways, and we were building the chips that connected those highways. We were not necessarily building the computing chips, but we had a front row seat to what was happening on the AI side. So we were working with the big hyperscalers like the Googles, the Microsofts, the Amazons of the world, and we were getting a very good idea of the fact that they were spending a lot of their time trying to solve the training problem. And the training problem, is one part of the whole AI computing problem. The second part is really the AI inferencing problem. And it seemed like at that time, back in 2019, there were not many companies really focused on solving that problem. And our thesis was, you know what, that will go on to become the much bigger problem compared to training. And it's very logical because you train a model only so many times, but then you deploy and use the model infinite number of times. So the inferencing problem logically would be much larger than the training problem. And we just felt that it made a lot of sense for a team like this to go find a computing solution that would efficiently run inference at scale. And when I say at scale, it could be in very large data centers to smaller data centers to even in certain edge applications, right? So we wanted to go back to first principles and create a computing platform that would allow us to serve the inferencing market when that emerged.
So this is like when I put a prompt in something,
right.
whatever happens at the back end is...
Correct. That's inference. That's a classic example. You talk to any AI model, call it ChatGPT, you prompt the model and the model kind of responds back with an answer. That's inference happening there.
And you think your thesis is proving correct? Inferencing is where
I think so. I think I like to think that pre ChatGPT and there was questions about how big the inferencing market would be. Post ChatGPT, there is absolutely no doubt in anyone's mind that that's just the beginning.
And you actually started before ChatGPT.
We started well before ChatGPT.
So you had not really anticipated this kind of LLMs and all that, is it?
We had not anticipated that it would become so big so quickly, right? We knew it would become big someday, but I think what surprised even the team at Dmatrix was how quickly that happened. It literally happened within 3 years of us starting the company, and at some point we were trying to run quickly to play catch up because this happened so quickly. There's no stopping it now. I think the genie's out of the bottle, and everyone wants to figure out how they want to use inference, how they want to use AI for their specific use case. So the inference market, in our opinion, is going to be 80% of the AI computing market. Training today is much larger, but over time, look out 5 to 10 years. Inference is going to be 80% of the market. Training is probably going to be 20%.
Okay. And your thesis is that, obviously, this AI models and all are consuming crazy amounts of power, huge energy costs involved. And your thesis is that this is unsustainable and you need chips, hardware infrastructure, architecture, etc., which can cut down cost.
Correct.
Without which this is all unsustainable.
Correct. Yeah. And our thesis is exactly that as inference becomes more important, again, keep in mind, the number of people on the planet that do training is a smaller community of people who do very large scale training. It's you can literally count the number of folks who do that on your fingers. There's probably 5 or 6 companies on the planet who can do that and afford that. But inference is for everyone. Everybody wants to do inference. Once you have a model, you want to either distill it down into a smaller model or fine tune it for your specific use case and deploy it. And that is for everyone. And if you are down a path where you're building bigger and bigger models on very inefficient computing hardware, then you put yourself down a path on a trajectory where you are going to hit a wall. You are going to get to a point where things become unsustainable. And our thesis is, we want to change that now. The further down the road you try to change that trajectory, the harder it becomes. So you want to change it now as soon as people are kind of understanding the importance of inference, and inference is slowly kind of penetrating into different organizations. Now's the time to come in with a new approach to how you do compute for inference that completely changes the trajectory on, whether it's power consumption, cost, the user experience. All these things can be influenced with the right kind of inference platform.
Okay. Let me just clarify. You're building a chip, is it? Or building software on top of that?
Yes.
The chip itself also is different?
Correct. So the chip is fundamentally different. And then we build the software on top of that. And we also build, and the chips are then packaged on what we call accelerator cards. And these cards go inside a server. We don't make the server. We work with the ecosystem to build the server. But our product is chips and the cards and the software.
Okay. Sandeep, do you hear similar concerns being raised about the kind of costs that AI will mean for, infrastructure costs in general and the energy costs that the planet will have to pay? And
absolutely. In fact, when Sid was speaking, it was music to my ears, because when I speak to customers, number one question being asked of us as hyperscaler is, how do we make it efficient? You said efficiency, right? At scale. There is innovation that has happened where intelligence is available to all of us. There's innovation underway to make it efficient. Two swim lanes. Sid was talking the second swim lane, which is how to make it efficient. I think it's definitely timing is fabulous right now because these questions will only multiply because inferencing is the real deal here. Because when you use ChatGPT as an example, a co-pilot, when you're asking questions, it's actually inferencing for you, right? It's generating output, it's inferencing. Now, train in the cloud because training requires massive compute, right? And when it comes to deployment, it's all about inferencing. Deployment can happen anywhere. So the time is now where we're seeing intelligence being available to all of us. And the choice in terms of where to run intelligence also is a choice that all of us have right now. So questions on efficiency, accuracy, safety continues. But the foundation question being asked is, we cannot run like this, where we're throwing more compute. So we have a responsibility to be sustainable. How are we making sure it's sustainable? See, on one hand, you're saying we're going to power our data centers by clean energy. That's one way. Doesn't mean that energy consumption goes up just by the fact that you're powering by clean energy. Doesn't mean you can throw more compute. But the question is, how do I consume least compute yet drive that same safety accuracy as you go along? So in my view, there is innovation research happening on the training front. How do we train using less compute? That's number one. Number two is, after inferencing is done, how do we ensure we can deploy that at intelligent hardware? Now, intelligent software is something which is given, but hardware being intelligent enough to drive optimum efficiency, accuracy, with utmost focus on guardrails. That's the future. Now, I said earlier, efficiency at scale. You've seen few innovations globally where this efficiency at scale has been addressed. For example, ChatGPT, in my view, is the first UI to AI. We never had UI to AI so far, right? It's all was behind the scenes for us. The first UI to AI was ChatGPT, honestly, and all of us witnessed it. That's the biggest POC on the planet running at scale, right? Of course, we had, let's say, Google and Bing search engines, which were running at scale. But this is another one. So now the question is, every enterprise wants to emulate how ChatGPT runs for their business. I want to have my own ChatGPT for my application. For example, let's say you're in the media business. Now you want your publishers to have access to such a tool at scale. It's not the question of empowering one or two people. Empower every single individual. That means scale. Scale requires innovation to happen in software, hardware. And everything Sid said, honestly, those two swim lanes will converge in future. When the convergence happens, you probably have reached a stage where, now we can scale. Now, scale is also a question in terms of cost. So right now, at times, it is cost prohibitive. Since ChatGPT to so far, the cost has come down by 30x, as an example, right, using these models. But scale is still a question. So that's where hardware innovation becomes critical. I'm glad innovation is going in parallel with software innovation. I think inferencing is the future. I agree with Sid in terms of, right now training is where bulk of energy and research is going in. But eventually, it's once you train the model, deploy at edge or deploy anywhere you want is a reality. But of course, training is not a one-time thing. It's a continuous thing, right? Because with more data, you want model to be aware of you in the context. So training also is almost like an iterative approach, and deployment is also an iterative approach. So the iteration to be reality, efficiency has to be struck. That's where scale will happen.
I want to ask Pradip also this question, but before that, Sandeep, tell me, since you work in India, you work with a lot of developers here, I'm sure, startups and all that, have you heard them raising concerns about the kind of costs that this involves?
Yeah, see, for startups specifically, the future is where most startups investing is to basically build IP on top of foundation models. That means they take large language models or even small language models and build IP on top of it. And building is one for sure, but again, when it comes to deployment at scale, that's where cost comes in. Because initially, you have access to data through any enterprise, or you might have your own data. You would eventually building a product is almost like building an IP on top of these intelligent models. Once you do that, it's about scale. And hence, at that point, the question of cost will definitely come, right? Yeah. So that's where we have to look at efficiency, because it's a volume game. People realize that this is not a bubble. Here and now, it's real, more than ever before. The question is, how do we make it available to everybody?
Okay.
So that's where the efficiency comes in.
Okay. Pradip, same question. India has a lot of AI developers. people around the world tell us that Indian AI developers are very good and all of that. They're developing great stuff. But when it comes to cost, especially for startups and all that, do you think cost will become a concern, as Sandeep also said, especially at the time of deployment?
Correct. So one big advantage that we have as a country is that is our large demographics that are youthful, and many of them are going to look for going into developing AI applications. So there is an application layer, software layer, firmware layer, and there is hardware at the bottom. So to develop the application, it's going to require a very robust infrastructure of application, below application, which is the firmware and the software. And that firmware and software is going to run on a very sophisticated hardware platform, right? So how would these developers have access to the hardware? And that's where a company like Dmatrix and the technology that Dmatrix has is a differentiation. For more than 3 decades, we have been doing load store architectures across the board. And here we have made a paradigm shift in the architecture of the processor, where we're going into in-memory compute, which is truly computation inside the memory. When you do the computation inside the memory, the power comes down by a large factor because you no longer have the data movement, and performance significantly improves because you don't lose the latency because of the data movement, right? And this level of hardware capability of a multiplication factor in performance at a significantly lower power at an affordable price point, that's where Dmatrix positions itself, right? And what government of India has been doing is, its journey has been going on to groom the talent, transform the attitude towards going into entrepreneurship. So, 3 decades ago, government jobs were the most important priced employment place. Then came the time of multinational companies and private sector, and that became very reputed. And I think government has been very systematically trying to take the current and the previous generation of graduates to think about going into entrepreneurship. And AI is going to really proliferate opportunity to develop applications for Indian consumer to address their pain point at their price point. And where would they get the hardware access? So that's where the programs like AI Mission come in, where government is going to provide access to hardware platform to entrepreneurs in India. So this is a story in development, but all the right moves are being made.
Right, yeah. The government is making a serious effort to try and democratize this as much as possible. But like you all said, if you can make it affordable, it becomes so much easier for a lot more people to participate. Sid, tell me, the point that Pradip also made, your technology itself, in-memory computing. The first time I remember hearing about, which was in the context of SAP, Vishal Sikka was trying to talk about in-memory computing and all that. Yes. That is when I got a hang of, a little bit about in-memory computing. So how much difference does that make, and what did you have to do, in terms of technology, IP and all of that to bring that to the market?
Yeah. So very different. The in-memory computing that SAP talked about
is more
software.
Okay.
Yeah, and how they put the database, the SAP database is kept inside memory, so it's more of a software. They play tricks with the software in terms of how they position the database in memory. What we have built is a grounds-up foundational, computing paradigm that has never been done before. People have researched this for years, the idea, but at the core of it, it's a very simple idea, right? Like when you look at an AI workload, right? You talk about ChatGPT or any other type of workload that is AI or deep learning. What's fundamentally happening there is data and there is compute, and the data is kept in memory, and you have a compute engine, and the data needs to be taken from that memory and moved to the compute, and then the computation will happen, and then after it's done, the data gets moved back into the memory. And that process of moving the data back and forth is very time consuming. It is energy consuming, and obviously it limits the amount of throughput of how much work you can do because you're spending time doing all that transfer. We just came up with a very simple concept where we said, given that this is what is primarily happening when you're trying to do computations with AI, how about if we take this memory, which has all the data, and convert it into a computer also? So instead of having the separate compute engine here, which is trying to get all the data from the memory, just take this memory, take this out, just move this inside the memory, and the memory now becomes a computer. So the data is sitting right there, right? And the computation is also happening right there. So now suddenly you minimize the amount of data that you're moving back and forth, which means you saved a lot of energy, you saved a lot of time, and you're able to do a lot more work because of that. And that is the whole argument of efficiency. And that's what inference at the core of it is all about, is doing more with less. And in-memory computing is one of the core innovations at Dmatrix that enables that efficiency of doing more with less. Doing more compute with less energy, doing more compute in less time, and doing more compute, period. So all this becomes possible because of this in-memory computing architecture.
Give me an idea, some metrics around how much of energy can be saved, how much faster things can be done.
Right. So the classic energy metric that people use today is how much compute can you do for 1 watt of compute? If you had 1 watt of energy, right? How many? The metric is compute tops, right? How many compute tops can you run on a single watt of power, right? And today, traditional GPUs can probably do about 3 to 4 or 5 per watt, right? We can do 100. So that's an example of the efficiency we can bring when we run inference on this type of architecture.
Okay, so you're going to beat NVIDIA and all hands down on the inference side.
I think for certain class of applications, we have optimized around those applications a lot better because the GPU is, in general, trying to be a lot of things to a lot of different people. We are not trying to be a lot of things to a lot of different people. We have said, let's go optimize around inference. We don't run graphics on this. We don't run HPC on this. We don't run training on this. We just run inference. And so obviously, when you focus on one task versus multiple tasks, you're obviously going to be better at it.
Like that. Okay. Sandeep, tell us, there's a lot of small language models and all being talked about. Those kinds of things, would they require less of compute power and all of that? Will that help Indian developers?
No, absolutely. I think the future would be people taking SLMs, small language models.
So what is a small language model?
So if you look at, dominantly, there are two breed of models. Large language models, that means you have more data, more compute, larger than life neural network, right? That's large language model that continues to grow. That means you're throwing more data, adding more compute, and you use a term called parameters, right? People say, this model is 500 billion parameters, trillion parameters, etc. It just increases. That's where intelligence also grows. Now, that's not a scalable thing. There's a fourth vector, right? Which is if you bring in high quality data, you can use less compute, right? Less data, less parameters, and create SLMs, right? Which probably will do one thing really well. Large language models, open web data, it can do many things. It's almost like the analogy I can give, Sujit, is LLMs are equivalent to a student going to university and doing PhD in multiple subjects, right? Multiple times. That's LLM. SLM is same student going to university doing PhD in one subject really well, right? Same PhD multiple times to get accuracy, right? So that's SLM. So with SLMs, you need smaller footprint. It is right now accuracy-wise not there yet, but pretty close to large language model performance on a few subjects, right? So hence the future would be you take SLMs which are already intelligent, which can give you fairly accurate responses, but bring in your context. Because SLMs have no context of who is asking, why they're asking, and what business it is. So I have data as a business. I bring in my context and train it. There's a term called fine-tuning. You fine-tune the model with your data using SLMs, which will give you an all-new SLM, which knows you really well, relevant to you, and a lot more accurate to you on your business. The future, as we're seeing, where we're seeing a new trail emerging, is enterprises gravitating towards SLMs because of the fact that it consumes less energy, less compute, and you're flexible deploying at edge also. Because large language models need supercomputers to run, large infrastructure to run right now. Right? If you look at ChatGPT, runs on Azure, it's backed by supercomputer. If you want to run LLM, you need that massive infrastructure. So not every enterprise can afford that infrastructure. which is where SLMs basically become a lot more relevant for enterprises. Hence, I think when it comes, let's say, Sid spoke hardware innovation. I'm seeing the future where I have choice of what hardware I want to use, and choice of what models I want to run, and choice of where I want to deploy. So anytime, anywhere, any device, which is the philosophy we've been seeing for the long time in mobile world, will be taken to the AI world with LSLM leading that particular discussion.
Okay. So these small language models also, do they link to the large language models?
Not
in
at
some
all.
way? No?
There's language models which is completely independent, intelligent models, but smaller in nature. As I said, the student knows one subject really well, not all subjects intelligence, which is the LLM.
Okay.
So SLMs are miniature in form. I would say it's almost like you packing everything in the refrigerator. You packed it, right? LLMs is like a supermarket open, but SLMs like a refrigerator. You have so much inside it, but that's relevant.
Okay. Sid, Pradip, I mean, in the SLM context, how does your solution work? I mean, the right solution for that in
We love it.
enterprises?
We love it. I think that's the, talking about sustainable inference and making inference available for everyone. And we are firm believers that inference is for everyone. And, the only way to kind of allow AI to go mainstream is to make it affordable for everyone and to make it easy to use for everyone. And SLMs are a big part of making that possible. So, I think the trend with SLM started right after ChatGPT, right? I mean, the world was down a path of bigger is better. And there was plenty of data to suggest that was true. Like the bigger the model became, the more data you trained it with, the smarter it became, right? And I love the analogy that Sandeep just made, that these are they're very generic in their capabilities, but what about folks who want to do a very specific task? It's like a PhD student, right? I specialize in a few things, but I do it really, really well. And very quickly, the world realized that we don't need to be on the bigger is better path for that to happen, right? And there was almost like a bit of a U-turn where, there was two paths that got created. There was one path that is down the AGI, super intelligence path, where the models will keep getting bigger, and that will continue, and that should continue. Yeah. But there is a separate stream on SLMs where the models are nearly nowhere as big as those. They're highly distilled from the big models. You distill down these smaller models, and then you tune them and you make them capable for a specific set of tasks. And that's where SLMs can be very, very beneficial to enterprises, because enterprises have, limited set of tasks they want to do really, really well, depending on, what your business is. And SLMs are exactly solving that problem. And, cost-wise, they're a lot more economical to run. So, and that's where a Dmatrix-like solution would shine, because we are able to take that class of models and just do a lot better job with inference than, say, a general purpose GPU would be able to do.
Sujit, if I can add, imagine a world where you're in airplane mode on your phone, but have access to the best intelligence. That means you're working in disconnected environment. In the flight today, when I go airplane mode, I have no access to my Copilot or ChatGPT because it's disconnected. SLMs, if they run on my phone, yes, the same intelligence is available to me 24/7. I don't have it connected at all. Almost like saying ChatGPT in airplane mode on my phone is a reality, and that for that to be reality, SLMs will make it reality.
Okay. When you say distilling from the LLM, what are you distilling exactly?
So look at it this way. Today, for us to train any model, eventually you need data. Now, access to data is not available to everybody. You need to create synthetic data. Data which looks real, represents the world. GPT-4, honestly, was that pivotal time where you could actually use GPT-4 to create a synthetic data, high quality, textbook quality data, to be leveraged to build SLMs, right? That's one. Second, by the way, you can also use LLMs to train SLMs, right? What does that really mean? That means I am pumping in new data, synthetic data, but I want you to verify factual alignment of SLMs inferencing in real time. And you don't need a human being to do that. because these LLMs are intelligent, smart. You can task them to train them. So, lot more usefulness of these LLMs to build SLMs for sure. But one large use case we're seeing is ability for us to create textbook quality data using LLMs to be used to train SLMs.
Okay.
That's a huge use case.
Okay. Okay.
Right? See, today, if I'm a startup, I want to build something in fintech. I don't have access to, data in the financial world, but I have an idea. I need data. I can use LLMs to actually create real-time data that looks like created with real-time world using LLMs, because all I can say, hey, GPT-4.0, I need this data, and this is the parameter, these are the dynamics of the business. Create it, it'll create for you.
Yeah.
Human to create that would take years. So LLMs comes in handy that way.
Okay. Okay.
Yeah.
Pradip, tell me, so in this context, we're talking about, Dmatrix, the kind of solutions that you are offering that provides for Indian developers in particular, huge advantage over competition?
Yes, it is. I think cost would be one key differentiation. Accessibility would be another major differentiation as well. Thirdly, the level of technology differentiation that's been offered. So you look at it, solution A takes this long to do a job versus solution B takes half of that, right? So therefore, how many more users can be accommodated on the same hardware platform, so to say, right? So accessibility, efficiency, and cost. On all these three angles, our solution by far, as we know today, really outpaces everything else out there.
Have you started piloting with any Indian developers yet?
We are on the cusp of it.
Okay.
Yes.
Okay. Globally, what pilots and all that you've done so far, customers very happy?
They're very happy. They see a lot of promise in the product. So yes, we are, as Pradip said, we are on the cusp of announcing this product, and it's been a long journey to get to this point. And we have piloted this with few large customers who would be able to give us quick feedback on what is possible with a product like this, and it's been overwhelmingly positive.
Have you seen the costs kind of make enterprises slow down at the moment? The general costs of infrastructure and all that. Is it stalling GenAI projects in any way?
I think cost is certainly a big part of the equation, but I think it's not only cost.
Okay.
I think it is cost and the and part is really the usability part is, okay, how do we take what we have today? We have most enterprises run applications, whether it's Salesforce or an Oracle or Microsoft Office 365 or whatever. These applications may not be AI native today, right? Because they were never really built with AI in them, and the transition is underway. So all of these applications are being made AI native and are being infused with AI. And a lot of the companies are trying to figure out, a lot of the enterprises are trying to figure out as they go through that transition, right? How do they use that for their specific use case, right? So there's a usability question, which is, I know I need to do something. I have the tools in front of me. How do I marry the tools with my specific use case? So I think the usability question is more important today than the cost question, because once that usability question is figured out, then immediately the very next question is, oh my God, I figured out what I'm going to do with this. I have every person in my organization wants to use this. I can't afford it.
Then the cost becomes.
I can't afford it. And
Yeah.
so now you go to the cost question.
Sandeep, application-wise, what are you seeing in India, even globally?
Yeah.
Where are the biggest applications happening? And do you see people getting worried about costs going forward?
I would say right now, if there is one worry for enterprises is, do I have a single version of truth? I'll tell you why I say that. Because generative AI, you don't have a magic wand. It's not 100% accurate. It feeds off your factual data. And if you don't have factual data, what you get out of generative AI when we ask a question may not be accurate. So you need to invest. A lot of enterprise right now, tell you what, they've realized the value of it. No going back. there is no going back at all, right? The interesting part, Sujit, this time is as a platform creator, you don't have to convince people on the value of it, because value is perceived in a consumer space with ChatGPT.
Absolutely.
Largely when innovation happens as enterprise, we go to customers to showcase, hey, this is a new innovation, it's going to add value. But no, they're saying, you know what, we've seen it adds value because our dinner table conversation is ChatGPT. When they go back to the offices, the question is, we need to make this real. For them to make it real, they need to have a single version of truth. The biggest hurdle for enterprise today is, where is my data? So getting that data together, because when you ask a question to an AI, like a large language model, small language model, it actually finds information in your enterprise. The information source has to be sanitized, approved, given a print, you know what, it's authentic. Then when conversations happen large in enterprises, they'll be authentic. Because imagine you ask a question to this innovation, hey, how many employees work in my company? It's a real story, by the way. One of the customers said, GenAI is not working for me. And the reason they gave me, Sandeep, you know, I have an application we built, simple application. The question being asked by my HR fraternity is, how many employees work in my company? Every day it gives me 2 answers. It can't be reality. Now, when they did a post-mortem, they realized there are 2 back-end systems, which are, one is a legacy system where the numbers exist, the new system number exists. So it's generative AI you have to fix that. So to question, enterprises largely realize the value. There is no going back. The question is, how to make it real at scale? Let me go and fix my data. Single version of truth. Number 1. Number 2, people. See, for me, it's clearly realization in the last 6 to 8 months is becoming more prescriptive here. People, data, and compute. I spoke about data being single version of truth. You need to have for people to understand the space of innovation. This is never seen before pace. So somebody has to constantly look at, hey, will SLM make a play here? Should I go for LLMs, or should I invest in the hardware, which is compute, right? So these decisions cannot happen without having a holistic knowledge on what's happening in the world of technology. So you need people also. And finally, compute, because the question is, nobody thought about compute all these days, because hyperscaler gave you the service. Now, for you to have a business model or innovation that happens in a very, I would say, portfolio-based innovation, where I have a portfolio innovations constantly happening, because it's not a one solution. You'll be actually building solutions which basically will empower people. Now, unless I have a infrastructure in place which is commissioned for me, and that's smart, which is sustainable, which is efficient enough for me to have an iterative approach towards training and eventually deploy for inferencing. So people, data, and compute becomes a strategic move for enterprise to succeed in this world.
Okay. In terms of applications, where are you seeing the biggest applications?
2 streams in my view. Where people are seeing enduring value of generative AI is, one is customer support, customer service. Absolutely, there's no question asked. Second, of course, is enterprise knowledge mining. Straightforward use case. I have so much of information in my organization which nobody has access to, nobody knows how to access it. Let me build a facade on top of it. The facade is the generative AI facade. Ask me anything facade. Imagine, if today you have to search for information, right? What if you can ask anything? Hey, I want to understand, when was the last time we spoke about hardware, innovation in a panel discussion? Your question to your ask me anything. It will figure out a way to find information, respond to your question. Otherwise, you have to make 25 calls to find out when was the last time. So building a facade of generative data on top of your enterprise data, which should have a single version of truth, is the second use case. So these 2 streams are absolutely no-brainer, low-hanging fruit. Every enterprise is by default going in that direction right now.
Okay. Marketing and communication?
Everything. I think I gave you horizontal streams, but every domain, every entity within a customer. By the way, legal department also not left out in that company. The general counselor is looking at, how do I basically look at contractual data that we have stocked, and how do we make sure we're legally bound? So let me ask anything. So knowledge mining is a straightforward use case, because you don't know what you don't know, right? And nobody will tell you that. But you have a natural language query which can be understood by your generative AI today. See, the intent was never understood by systems so far. We use a term called human-computer interaction, never reality. Now systems understand us. You ask a question with incorrect English, with a lot of mistakes, systems will understand your intent and go and fire up a query to fetch information, respond to your question, right? That's reality. So absolutely.
Yeah. Sorry, Pradip.
Sure. So in the India context, I think healthcare, taking it to the remote places. and tying the rural remote areas back to the city through the AI infrastructure. That's going to be a big booster of generative AI and its application.
So it'll work like how?
So you have remote diagnosis capability that are partially handed over to the remote automation, and the processing could happen in the back end where the larger hospitals in the city are available.
Okay.
So that really provides a deep penetration of a decent quality medical care to rural areas where we usually find challenges today. Right? So healthcare, I think in next 10 years, is going to be a major beneficiary to India and the quality of life in India because of AI.
Okay.
Second one that I see is education. Again, same analogy. When we look at government schools or when we look at schools that are in remote areas, right, quality of education differs. And now, at cost, by bringing automation built by AI, you can offer kids in schools the same quality of education that it's agnostic now of where you live. You'll have that at fingertip access, like the way cell phones have penetrated India, right? Third one is agriculture. That's going to be a huge beneficiary. Agriculture, 70% of the population is affiliated with it. You can just a multiplication factor to their productivity, right? And fourth one is finance. And this is where, we want to be a $1 trillion economy. I think we have all the ingredients in place. This is going to really accelerate with certain very specific applications that could lead to productivity enhancement that would translate straight into the GDP. Right? It will also identify the sources of income for the country from within the country that would generate the revenues of the government. Right? So these are the four fields that I think India would tremendously benefit out of AI. It's probably in a 5 to 10 years window, but we have positioned ourselves really well with Bhashini so that AI can go to the last mile of a consumer in every of the 27 Indian languages. Right? And I think that is a first very important step that is going to be an enabler. But this four field, the finance, the healthcare, the agriculture, and the education.
Yeah, no, you're very right. I mean, on the language side, there's a lot of work happening, a number of companies kind of working on it as well. But talent-wise, Pradip, all for this application side of things, as well as you're trying to build a center here for the kind of semiconductor work that is happening. Talent, how good is it? Enough to scale?
Right. So I think for last, I would say 3 years. So by the way, I think in India, we have that seeded mindset about STEM subjects being a good career option, right? So kids are vast majority of kids are positioned towards careers in the STEM subject. So that's very helpful at this juncture, right? Secondly, curriculum, right? And in last 3 years, AICTE, at that time it was under Dr. Rajiv Chandrasekharji, right, has taken a lot of very quick measures to realign the curriculum towards AI and semiconductor. And today, vast majority of the colleges offer software with AI. Hardware with AI is relatively lesser, right? And that's where, again, there is increased focus now. But we do see that universities are gearing up for modernization and preparing the industry-ready workforce in AI, particularly software and applications. So that is coming up. Existing talent in the country, I think AI in the country is not new, but where the premium talent is, right, motivating them towards smaller startup companies, right? That's a certain amount of effort. And there is a larger awareness now of the risk reward. And we, at least based on our own experience, we see that we are able to recruit and essentially cherry pick from some of the top brand names in the ecosystem.
One thing I'd like to add, right, is like 19% of the world's chip design talent is in India. Right, that's a big number. That means like 1/5 of the world's chip design talent is in India. So, I mean, it's not like there is no talent. I mean, multinationals have been coming here for years, and they have trained up a whole workforce of talent. And now it is, and given everything that we just talked about on this panel about how India is so well positioned in the age of AI, having access to this kind of talent here that is all trained up, I mean, it would be crazy of us not to take advantage of it, right? So we are very excited about having a presence here, and And I think, again, to Pradip's point earlier, that the government is working very hard to make entrepreneurship and startups a very attractive career path for a lot of students coming out of college and a lot of the folks who are already in industry. And you put the two together, I think we are seeing some pretty good success, bringing really good talent into Dmatrix that is both experienced, and in some cases we are hiring new college talent that's graduating.
No, you are very right. I mean, we are very good on the design side, particularly, I think, like you said, there's so many of these global semiconductor companies which have set up massive centers here.
Yeah.
But what are the hardware side? How do you measure the talent here compared to what you see in Silicon Valley and all that?
Well, it's world class. I mean, you have to look. But as the way we have approached building our talent center here is we have kind of picked talent piece by piece. We have high standards of who we want to bring into the company, and we are patient. We're not in a hurry to bring on quantity of individuals without quality. But the quality exists is the point. The point is that the quality exists, and yes, you have to look a little bit, but the quality does exist, and we have been able to find world-class talent in India. Right? They can measure up to pretty much any engineer anywhere in the world. And those folks exist here today.
If you want to build that talent, what would you recommend to youngsters? What should they learn?
I'm going to make my comments in the context of chip design and hardware. Right? Software is a different kind of set of needs. It's a patient game. I think for anyone who wants to build a career in hardware and silicon, experience, there's no substitute for experience, and you have to do a number of developments, make mistakes, learn, and grow from there. And it's a very capital intensive business, so the risk is very high. The risk reward is it has to be managed very carefully. So anyone, and the one thing for talent to remember, young talent to remember, is that when you accumulate that experience over many years, it is invaluable. It's very difficult to substitute. It's not something that can be learned overnight, right? It's not like there'll be a new trend tomorrow that could disrupt you, right? Hardware and chip design talent, you just become more valuable with time as you have the scars to show with all the different projects you've done and delivered real silicon and hardware into the market. There is absolutely no substitute for that. So you just become more valuable with time. The barrier to entry for other talent to come in is not easy because it is very it's accumulated experience.
The core will have to be what? Physics, chemistry, and all of that.
There is, yes. So some physics, some math, obviously, right? There's your foundational principles have to be circuits theory, right? And a lot of that is mathematics. And so yes, just basic foundations. Once they are in any good college, will give you that. Once you have that, the rest is experience, right? It's like when you're learning. I like to give an analogy. It's like learning, skiing. You can instructor can teach you skiing for a certain amount of time, but then after that is experience. And the more you are on the slopes, the better the skier you become, right? Going back to the trainer multiple number of times is not going to make you a better skier. Getting onto the slopes is going to make you a better skier. Same thing with this. You can learn so much in college, but you need to get into the game. The longer you stay in the game, the better you become.
You said the risks are huge in this chip design and development kind of thing, and yet you got into it. What gave you the guts, the courage to kind of do it?
Again, it's in the case of Dmatrix, starting it was a very risky venture, right? I mean, when I'm looking back, it's only I like to say hardware is hard. We all know that. Building chips within hardware is even harder. Trying to build a company that builds chips and hardware is insanely hard. So only stupid people would venture out and do that. And maybe I was one of those stupid people who did it. I think at some point it is you've gone on this journey. You've seen, you've stumbled, you've learned, you have the scars to show for it, and you wait for the right opportunity. And in our case, a very large opportunity presented itself. In the form of what was happening with AI computing. And we just felt, given where we were in our lives and careers, we felt we wouldn't have another chance like this one to make an impact, right? Something like this where we are creating what I'm undoubtedly sure is going to be the largest computing opportunity of our lifetime, right? The largest silicon, not just computers, the largest silicon opportunity of our lifetime. As silicon engineers, silicon, entrepreneurs, if we didn't take and capitalize on that opportunity, that would be opportunity lost. So we just had to just plunge in, and we said, you know what, we'll figure out the rest as we go, like everything we have done in our lives. But it was too much of an opportunity to pass up.
Okay. That inference inflection point is coming up, you think? Or when?
I think I like to say there's going to be 2 points, right? One is people just acknowledging inference is the larger opportunity. I think that happened with ChatGPT. So that has already happened. Now I think it is the second part, which is how do we use it, right? Yes, we know we need to use it, but how do we use it? And that, I think there's going to be another inflection point, which will, there'll be an aha moment to say, okay, we now understand this is the killer app. There are multiple killer apps. And me personally, at Dmatrix, we are very excited with what's happening with reasoning. So we didn't talk a lot about reasoning on this panel, but reasoning is there's a model called O1, which was announced by OpenAI just about a month ago. And that is a reasoning model. And what we mean by reasoning is right now, a lot of the AI models are what we call system one thinking. And an example of system one thinking would be if I asked you a question like, hey, what's the population of India? Either you know the answer or you don't know the answer. And you might say, you know what, I don't know the answer. I know the answer, and you'll say the answer. That is system one thinking. You have been trained on that data, you know the answer, and you'll give a response. Most of the AI models today, they operate on system one thinking. So ChatGPT, GPT-4, even we'll see what happens with GPT-5. But all AI models out there, most of them are system one responses. Now, system two response, an example of that would be if I asked you a question like, so Sujit, what do you think makes for a really good AI policy in India? Now, you're not going to give me a one-shot response. You're going to say, you know what, actually, that's a great question. Let me go look at the data. You go back, you do some research, you come back with multiple responses. You'll say, you know what, this response looks better than this response. Let me take this one. It might take you days, weeks to come back with a really good response. Now, that is where inference is going. That is where AI inference is going. Models will learn to reason, right? And they're learning to reason. And, that effectively implies
even more
capacity. Even more inference. So at Dmatrix, we are obviously very excited by that because clearly, that's how humans think. For, when it comes to important questions, that is where inference is going to go. That is where AI will go. And that to me is going to be that second inflection point. You talk about, what is that next inflection point? That would be the next inflection point where reasoning models really go mainstream. People at that point don't need to intervene with AI that much. Because right now what is happening is, I'm sure when you interact with AI, there's a lot of intervention. You prompt the model, you don't like the response, you reprompt it, and you don't like the response, and you reprompt it. It takes you multiple tries to get to a point where you say, you know what, I'm finally getting what I really like. With reasoning, you don't have to do any of that, right? It's all agentic. There are multiple trails running inside that model. You specify something in, high-level English and say, this is what I want to get done. And then the model goes down and breaks down the task. It runs multiple threads. It reasons, it thinks, it reflects, and then comes back with what it thinks is the best response. And I think that when that happens in a ChatGPT-like fashion, that will be the next big inflection point. And I think we are not very far from that.
Yeah.
We're not very far from that.
It's actually thinking.
Yeah, it's actually thinking.
Okay.
By the way, if you used O1 in ChatGPT console, it says thinking.
Really? Okay.
It says a thought for 6 seconds, 7 seconds. So it's chain of thoughts. See, as rightly system one thinking, we use a term called zero-shot learners. They just respond to intuitively. Whereas certain questions requires reflection. Every model can do that, by the way. You have to program it. But with O1, inherently they've built that chain of thought into the way it responds to you. So you can make the older models reflect and respond to you, right? That way it gives a lot more accurate response. It's like nobody writes code one time, right? You write a code, you polish it, you make sure it's refined for the best code that you write at the end of the day. By default, the model will give you one code, right? You might say it's giving without thinking. But of course, you can make the model think, hey, you know what? You reflect on your own response, refine it, and give me the best version, which is what we used to program till 4.0, till O1. Till 4.0 we did that. With O1, by default, it does, chain of thoughts inside. So chain of thought is a brilliant concept so that you always, don't abruptly respond, but think. No, we always say take a pause, think about it, don't respond. Models are doing that now.
Fascinating.
Yeah.
Sandeep, I just want to also get back to the topic on talent in India for both the chip design, the semiconductor talent, and building applications. A lot of youngsters sometimes listen to these kind of events. So, what is their message to them?
He'll tell you what, on semiconductor, I'll go with Sid's response in terms of, yes, that's a different stream altogether, hardware. Understanding the chip design, understanding the design thinking behind how it's all done is a different ballgame altogether. Having said that, even for software right now, even for AI era before ChatGPT is dramatically different from post-ChatGPT era. So you have to be a lot more literate right now to think about how does the model work, which one do I use, how do I use it, how do I steer this model towards how I want the model to behave. It's a whole new thinking. So for somebody who is at the cusp of, I want to choose the streams, yes, of course, software is the easy one because that's a lot more omnipresent. Hardware is absolutely, that's a niche area. So if you want to jump in, there are two trails for sure. But my message is, this is time to invest, to learn and go deeper on in this field of AI. I don't think you have a choice because everything that's getting built will have an element of AI, whether you get used to it or left behind, or jump in and learn. Continuous learning has to happen or left behind. So every academic institution is offering these new streams. Earlier it was electives, now it's mainstream. Thankfully, as Pradip was saying, Government of India and Education, AIC, they've invested significantly to make these electives as mainstream, which is essential for you to become a lot more literate in this world of AI. And hence, if you look at the stats recently, 1/4 developers globally are from India. So developer population is significant in India, and ability for them to be productive from day one, and they have to learn the new skill, which is how do I use AI to make sure my day in the life at work is a lot productive, a lot more efficient, and I go back home with contentment. It's also, while we're talking about this, it's also about, we say productivity. Bill Gates said this recently, don't ever look at generative AI to just, the measure is not output per hour, say. Look at creativity, delight at work. I would say, can this innovation bring joy at work? That's where you also look at making it real for businesses.
Yeah. I know GitHub put out the data recently about the highest growth amongst developers. And one of the reasons they said was this incorporation of AI and robotics and things into curriculum, I think.
Absolutely.
Pradip,
so if I may just add to what he's saying. So I think one of the key message for the students who are currently into the ECE major, or electronics and communication, or electrical and electronics, or electronics and instrumentation. These are the three majors related to electronics that eventually lead to career in chip design. Right? For those students, there are just two simple messages that we do, or that we give when we go to campuses. One is study the fundamentals really well. That's very important.
Fundamentals would be?
Fundamentals of electronics. Make sure you... A lot of students, after they enter the universities, they look up and say, okay, where my seniors are going? They're going to IT. Even though they are in electronics, they're spending more time preparing for IT job, right? And so the key message we say, if your heart is in IT, fine. But if you want to be in semiconductor, make sure you focus on electronics design fundamentals, because that's the step-in major entry barrier, so to say. If you're good in fundamentals, you step in. If you're not, 4 years will take you, else you are not into semiconductor. One thing. The second thing is attention to detail. So there are two laws in chip design that we consider very ubiquitous: Moore's law and Murphy's law, right? So Moore's law, what could go wrong will go wrong, and that is so true in chip design because it's in hardware. You can never rewrite and release a patch. It's expensive silicon done, dusted. If it works, great. If it doesn't work, it could be expensive. So attention to detail is extremely important. If somebody is just being casual about chip design, they may be great engineers, but if they're casual, they would not be able to pick up the momentum in the career, right? So developing the desire to have a good teamwork, because projects are so big, there's no longer one-man play or one-person play, right? So attention to detail and team play are good soft skills to have, and really strong knowledge of fundamental courses of electronics design. These are the two things as a message to the students who are in the subject. right? And regarding your earlier question about what are we doing with the Dmatrix to empower India ecosystem. So with our own platform, we are on the cusp of, so we are going to wait for the unveiling at an unveiling event that's scheduled in US, and then we are going to reach out. But one of the things that we are already doing for last 2+ years is we actually have a VLSI exhibit that has everything from die to wafer to packages of different kinds, package substrates, load boards, silicon bringer boards, and final product. So this is it is actually a mini museum which goes from sand to silicon to the system. And we have gone to, I would say, 50+ universities by now in the last 2 years. And we give students a complete hands-on exposure from 6-inch wafer to the latest 370 wafer.
You have all these.
All of this, absolutely.
Yeah. And you take this with you.
And we take this with us, yeah. And we give this exposure to students. And there is many times even HODs walk up to us and say, I've been teaching this for 30 years, so this is the first time I'm actually able to see what it is, right? And that real exposure is one thing that we thought as a hardware company that is now evolving into systems and solutions company with a lot of software focus as well. But that's one thing that we had, while we were building our solution, before we can give it out, we have been at the cause of skilling in India on a voluntary basis. So it's completely free of cost to the universities. And they invite us, we go there, we spend a day. Latest technology, which is chiplet. Kids actually can see a 16 processor chiplet based solution literally in front of them, and they can see a chip that was done in 3 micron and they see the difference. Right? So we have been at the forefront to ensure that we put something back in the ecosystem. We started with semiconductor, and I think very soon we are going to transition to AI with our own solution and take it to the universities, take it to the startup entrepreneurs, and try to support our ecosystem to have access to a very niche and a very expensive generally technology. But I think our intention is to help our ecosystem here.
And the team here that you have, that is focused more on what? And what do you see focusing on as in the coming
every
years?
skill vertical that we have in our headquarters has a presence in India.
Okay.
Right? And with that, we are on a growth path, right? So we always take with every new center. I mean, for me, this is third time that I'm in this role. So the right approach to build a robust site in India is to take a crawl, walk, run, right? And as a crawl phase in last 2 years, we have secured the trust. Through the execution, we have managed the credibility with our global peers. And there has been a fantastic one company culture that has shaped up, right? So as a result, the site is involved into all critical building work of the company and the product and the technology, right? So that's a very robust crawl phase that we just completed. Next is to go into walk and run. And I'm sure we'll be meeting many more times at various points of our growth in India as well as a company.
Excellent. Looking forward to that, seriously. I mean, this is the kind of companies we need in India right now. Absolutely. And with the semiconductor mission that the government is talking about and the fab and all that are in the works, I think this kind of talent will really help. Sid, last question. I mean, not really question. I mean, you can conclude this. I told me earlier that you grew up in Ahmedabad, right? And then you went to the US, and now you could be building a company that could possibly, rival even NVIDIA and all of that. Of course, everywhere governments are worried about the kind of energy use that is emerging, and you think Dmatrix can have a really big impact there, is it?
That's right. That's right. And that is one of the core underlying tenets of the solution that we are building is, we are down a path right now where we are going to hit a wall on energy consumption. Right. I mean, there are various data points that we can cite, but today, if I were to summarize it for you, the total amount of energy consumption in the world that is dedicated for AI, call it computing, is probably in the couple of 100 gigawatts of power. Right. It's small. I mean, if you see where it could go, I mean, it's still very large, but the numbers that are being cited. In the next 10 years, we could be in the hundreds of terawatts. So you're looking at a jump from 100 gigawatts to 100 terawatts. That is, a huge huge increase of power consumption.
And data centers as a percentage of
That'll
costs
it'll be
is
about
going
20%, 20 to 30% of global electricity consumption
will be
in 10 years, right? So it is unsustainable. I mean, at that point, today it is close to 2%, and we are saying we want to go to 20%.
20%.
Yeah. So it is something's got to give, and we don't want to burn down the planet in the process of finding the solution for AGI or super intelligence. That would not be fun. So I think our mission is about changing that trajectory, right? As inference goes on to become a bigger workload, which we are pretty confident will happen, and if inference is truly 80% of all AI compute, and we introduce a whole new way of doing inference computing that is a lot more energy efficient, then we will effectively help make a greener planet. And that is really, I think, a big part of what we want to try to accomplish.
Okay. No, absolutely. Every time we write a prompt, it's actually consuming energy. We don't
That's
realize
right.
it.
We take it for
But
granted.
I think as all of us write more and more prompts and all of that, the amount of energy consumption this is going to lead to is going to be crazy.
Right.
And the only way to handle all this, of course, renewable energy is one part of it. But ultimately, the efficiency of
You have to go to the root of the problem.
absolutely amount of compute that is used for any of these purposes has to become a lot more efficient, and which is the direction you are taking.
Right.
So thanks a lot, Sid, Sandeep, Pradip. Really nice having you all on this platform. Great discussion. Really looking forward to see how the company does in India. Thanks so much.
Thank you, Sudhir.
Thanks for hosting us today.
Thanks.
Bye.